Okay, so our lesson on perfect squares is you're going to be given whole numbers from 0 to 400. You'll be able to identify it as a perfect square. Last night's homework should be taped to page 7, just fold it in half, and then you're going to take the vocabulary to the top of page 8, which you can see here I have done. Alright, so let's move on. We're going to check our homework, then I've got a vocabulary and a video that you'll watch, and then we have a perfect square activity. Alright, so let's update your table of contents here. You can pause to see how to do that. Alright, next we're going to check our homework. In checking our homework, I gave you 2 examples. Here was the example if you have a positive power of 10, and here is an example if you had a negative exponent for powers of 10. Alright, so if we move on, 10 to the negative 5th power, we know that the negative exponent tells us it's going to be a fraction or a decimal. So we write the reciprocal of 10 to the negative 5th as 1 over 10 to the 5th power. We write the expanded form of 10 to the 5th, which is 5 tenths. Again, we know that that little 5 tells us how many zeros, so that becomes 1 over 100,000, and then that gives us our decimal equivalent here. Now, another way to look at this and think is that we know that 10 to the 0 power equals 1. So, if you start at 1 with your decimal behind 1, because that's where it really is, and if you have a negative 5, you move 5 places to the left because we're going to get smaller, 3, 4, 5, then you will end up with the correct decimal. You also can simply say, well, I have 5 zeros, I know it's negative, so I'm going to put 5 zeros to the left, and then remember where to put your decimal. Always 0, and this is tenths, hundreds, thousands, 10 thousandths, 100 thousandths. All right, moving on to the next one, 10 to the 2nd power, 10 squared, we know 10 times 10 is 100. 10 to the 0 power is 1, as any number to the 0 power is 1. And then we have 10 to the negative 2 power. We write the reciprocal, 1 over 10 squared. 10 squared is 10 times 10, 100, and this is our decimal. And then finally the last one, hope you can see it, 10 cubed is 10 times 10 times 10. 3 is our exponent, so that gives us 3 zeros, making it 1,000. All right, then here is, again, your examples for doing the bottom half. We're writing everything into a power of 10. So, for our first one here, we count 6 zeros. Or you can count how many places do I move my decimal to get it to where it would be at 1. Well, it's 6. So, 6 zeros gives us 1 millionth. Expanded form, that gives us 1 over 10 to the 6, and if it is a decimal, we know it is a negative exponent. Okay, here we have 9 zeros, so 10 to the 9th, which is 1 billion. Here we have the decimal 1/10, we write it as a fraction. This is our power of 10 to show us 1/10, which is a negative exponent. 1 is simply written as a power of 10 as 10 to the 0 power. So if you didn't get that, remember, 10 to the 0 power is 1. And so when 1 is written, it is 10 to the 0 power. Here is 1,000. We've got 3 zeros, so we know that's 10 to the 3rd power. All right, so moving on, you will determine the square root of a perfect square less than or equal to 400. Now, here's your vocabulary. Square root, one of 2 equal factors of a number. The square root of 25 is 5, since 5 squared equals 5 times 5, which equals 25. A perfect square is a whole number, whose square root is a whole number. So 25 is a perfect square because the square root of 25 equals 5. Because one side times the other side, using that 2 equal factors, 5 times 5 is 25. This square root symbol here is a radical sign. This is called the radical sign. It looks kind of like a check and an upside down check with a division sign. But it stands for square root, so the square root of 25. The sign, though, is called the radical sign. All right, moving on. Now, you're going to have this video. This video is going to be up for you on Edmodo. You just need to click on the video. This will help you to understand perfect squares, I think, a lot better. Because here you see that we have one square, so it is a 1 by 1. All right, here we have a 2 by 2. 2 times 2 is 4. So 4 is a perfect square. The square root of 4 is 2. Here we have a 3 by 3. We have here 3 times 3 is 9. The square root of 9 is 3. So I want you to watch this video as well. All right, then for our activity, you're going to need graph paper. So those of you that don't have graph paper, I will have some for you. We are creating a colorful square root chart for perfect squares. The chart must include geometric drawing of cubes to represent each square root. The cubes should have the respective side lengths of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And I'm going to show you mine in just a second as well. The cubes to correspond to the areas. So the area of a 1 by 1 is 1. The area of a 2 by 2 is 4. A 3 by 3 is 9. So you notice that I'm using counting numbers. Once you go and view the other video I was showing you about, you'll understand what I'm meaning by counting numbers. We're going to complete this making representations of perfect squares from 1 to 20, using our counting numbers 1 to 20, with perfect squares going from 1 to 400. Okay? Then this is going to be what you're going to put on the, once you fold it in half, and I'm going to show you again, you're going to have this example here, where you're going to start with 1, then you're going to draw a 2 by 2 square, a 3 by 3, a 4 by 4, all the way up till we get to a 20 by 20. And of course, 20 by 20 gives us 400. So the square root of 400 would be 20. You're going to also figure out the square root of what would, 19 would be the square root of what number? All the way down to 11, which you should know. So we know that, of course, 121 is the square root, 11 is the square root of 121. You probably also remember that 144 is a square root because 12 times 12 is 144. You can work on all of those all the way, 13, 14, 15, they'll tell you what that is in the video, 16, 17, 18, 19, and so forth. And I'm sorry that my board, you know how Mrs. Jordan's board gets a little off from time to time. All right, so now let me show you. I'm just going to flip. So now let me